We welcome you to our new series of videos where we pick each mind map from our mind map bundle and help you run through all the important points you need to remember for your exams. So, let's get started on biostatistics in this mind map. Correlation is a statistical measure that describes the relationship between two quantitative or continuous variables. It is often represented using a scatter diagram. The correlation coefficient is used to quantify the strength and direction of the relationship. The value of R ranges between -1 and +1. Different strengths of correlation are identified based on the value of R. A weak positive correlation exists when 0 is less than R is less than 0.3. A moderate positive correlation when 0.4 less than R less than 0.6, and a strong positive correlation when R is more than 0.7. Conversely, a perfectly positive correlation occurs when R is equal to +1, indicating that an increase in one variable corresponds to a proportionate increase in the other. A perfectly negative correlation, on the other hand, occurs when R is equal to -1, indicating that an increase in one variable corresponds to a proportionate decrease in the other. Moderately positive and negative correlations signify that an increase in one variable is associated with a rise or fall in the other, though not perfectly. When R is equal to 0, there is no correlation between the variables, implying that changes in one variable do not affect the other. Spurious or false correlation refers to situations where no particular pattern or relationship is observed. Different correlation coefficients are used for specific situations. Pearson's correlation coefficient, Spearman's rank correlation coefficient, and the multiple correlation coefficient are some examples of commonly used coefficients. The coefficient of determination, often denoted as R square, is a statistical measure that represents the percentage of variation in a dependent variable that can be explained by one or more independent variables. It is calculated as the square of the correlation coefficient R. The value of R square ranges between 0 and 1. Coming to the next part, regression analysis. Regression analysis is a statistical technique that helps establish the structure of the relationship between two quantitative variables. One important aspect of regression analysis is the regression coefficient. It measures the change in the dependent variable associated with a unit change in the independent variable or variables. There are different types of regressions that can be employed, depending on the nature of the relationship between the variables. They include simple linear regression, which is the most basic form of regression. The relationship between the variables can be expressed as y equals a plus b into x. Multiple linear regression, simple curvilinear regression, and multiple curvilinear regression. Now let's take a look at what confidence interval level and limit is. A confidence interval is a range of values that is likely to contain the population mean when obtained from repeated samples. The width of the confidence interval is influenced by the sample size and the standard deviation. A larger sample size leads to a narrower confidence interval, indicating more precise estimation. Similarly, a smaller standard deviation results in a narrower confidence interval. The next one, confidence level, is the degree of assurance or probability that the interval contains the true value of the parameter. It represents the level of confidence we have in the interval estimate. It is important to note that achieving 100% confidence is not possible. A commonly used and internationally acceptable confidence level is 95%. The confidence level is denoted as 1 minus the significance level alpha and is associated with the maximum tolerance of the probability of a type 1 error. Lastly, confidence limits refer to the upper and lower boundaries of a confidence interval. They define the range within which the population parameter is expected to lie. The confidence limits provide additional information about the precision of the estimated parameter. As we know, statistical errors can occur in hypothesis testing. There are two main types of errors. Type 1 error or alpha error occurs when the null hypothesis is true, but we mistakenly reject it. The probability of type 1 error is represented by the p-value. A p-value less than the chosen significance level, often denoted as alpha, is considered statistically significant. In hypothesis testing, we aim to keep the type 1 error rate or alpha as low as possible to minimize the chances of falsely declaring a significant difference when it is not present. The next one is type 2 error or beta error. This error occurs when the null hypothesis is false but we fail to reject it. The probability of type 2 error is denoted as beta. It represents the chances of failing to detect a significant difference when it truly exists. Type 2 error is considered less serious than type 1 error, but it can lead to missed opportunities to detect important effects or relationships. But what is a null hypothesis? It is the hypothesis we initially make when we have to prove a particular hypothesis about the difference between two regimens. What is the power of a test? It is the probability of correctly rejecting the null hypothesis when a clinically significant difference exists. It measures the ability of a statistical test to detect an association or effect when one truly exists. The power of a statistical test is equal to 1 minus the probability of type 2 error or 1 minus beta. A higher power indicates a greater likelihood of detecting a true difference or relationship. The power of a test can be increased by either increasing the sample size, reducing the probability of type 2 error, or by increasing sensitivity. The power of a test is often considered when calculating the sample size required for a study. It is considered a numeric representation of sensitivity of a test. Lastly, you can go through the validity of a test, validity of a criterion, and learn in brief about the Delphi method in the other key points section of our mind map. We hope we have made this quick revision easy for you. Stay tuned for various other mind map explanations. And in the meantime, you can head over to the MCQ section of our app and challenge yourself with a few important MCQs. Good luck!